Chapter 5 continues the study of functions. It talks about passing variables by reference, and I already posted a video demonstrating that. We're going to do, for this guided practice, number 5 from the programming projects at the end of the 9th edition. This is number 14 in the programming projects in the 8th edition, and it's a problem where it asks you to calculate the wind chill. So it reads, in cold weather, meteorologists report an index called the wind chill factor that takes into account the wind speed and the temperature. The index provides a measure of the chilling effect of wind at a given air temperature. Wind chill may be approximated by the following formula. W equals 13.12 plus 0.6215 times T minus 11.37 times V to the power of 0.16 plus 0.3965 times T times V to the power of 0.016, where V is the wind speed in meters per second and temperature is in Celsius. I'm going to create a new project and call it last name first initial. I'll do 5-5. If you're in the 8th edition, do 5-14 for me. And then I'll also call it wind chill. And I'm going to create a new folder for it. Something that this chapter also touches on is building subroutines for all tasks, or building functions for all subroutines. So we're going to do that in this project as well. And what that means is kind of cleaning up your main and even retrieving the data, the user prompts. We'll put those into a separate function as well. Okay. Add my using directive. Okay, so as I just mentioned, we're going to create a function that actually handles getting the data from the user. I'll start by declaring my variables in the main function. And we're going to pass these variables by reference. So this is another exercise, or it's our first guided practice in which you will be passing variables by reference. And remember what passing variables by reference means. The function that you pass the variable to does not create a new storage location and duplicate that information. You're passing a address to the location of the variable, so any changes made to that variable will be reflected in throughout the program. So I'm going to create a double for wind speed, and then another double for um, degrees Celsius. And I'm going to create a function that retrieves the data from the user. And I'll just call it get data. Okay, since I'm passing by reference, this get data will be a void function, and it's just going to be changing the actual storage location that we've declared here. So this function needs to have a declaration. So up here at the top, I'll create this void function, get data, declare this void function, get data, double, and passing by reference. Okay, and I didn't even call it the same thing as I did here, and you don't have to. These names, they don't have to be consistent throughout. It's the data type that's important, whether it's being passed by reference or value, and then the data type returned here. So I'll give a description of my function. Gets wind speed and temperature in Celsius from the user by reference. Okay, so I'm going to have my output statement here. And I'll say the wind chill index is, and I'm going to call my function directly from the cout statement. So it will return the value back to the cout statement. So the only place these variable names need to be consistent is, of course, within the scope of the function itself, wind speed. And we're passing these by reference, so this function is going to actually manipulate the data in that storage location. This function also needs a declaration. Double calc wind chill, and I'm going to pass those by reference as well. And my description for that function gets the wind speed and temperature in Celsius and returns the wind chill index. Okay, now I need to write those two functions, or define those two functions. So void get data, in the get data function, I'm going to validate the user's input, something else that we are needing to do in our programs that we haven't done yet. So if the user doesn't supply valid data, then the results of the program are going to be meaningless. Notice in the program project description where it says the temperature in Celsius has to be less than or equal to 10 degrees. So this function doesn't work if the degrees Celsius is greater than 10. Okay, so we're going to validate that user data with a loop. And I'm going to have a do while loop here. It's going to prompt the user for a temperature in Celsius that is above, or I'm sorry, under 10 degrees. Read that value in. Okay, and then that while loop, that do while loop, is going to continue while that degrees Celsius temperature is greater than 10. So that's going to ensure that the temperature that the user types in is greater than 10, and the function will hold true. And then next we're going to enter a wind speed in meters per second. And for the wind speed, we don't have any user input validation. The wind speed could be whatever. If the user did type perhaps a negative value, what you should, what our pre-engineering students would know from physics is that negative values in a velocity or in a speed is just going to indicate direction. And that just makes it a vector. So then that we would have a velocity vector as opposed to a speed scalar value. So that function should get my data. And then now I'm going to write the function that calculates wind speed. Do that here, define it. Double calc wind chill. I'm flopping back and forth between temp C and degrees C, just demonstrating here that these variable names don't have to be the same. We called it degrees C here. In the function declaration I use temp C, and I use temp C here. The names only matter for the scope, which is the from open to close curly brace. Okay, so this function is going to just return, and the function 13.12, and I'm just going to hard code in these numeric values. 6215 times temp C minus 11.37 times, and I'm going to use that power function again, power the velocity or wind speed, and we're raising it to the power of 0.16. Multiply by 0.3965 times that temperature in Celsius times power function again. This time we're taking wind speed and raising it to the power of 0.016. Okay, so even though as I mentioned in the previous chapter 4 guided practice, even though the power function is recognized by the compiler, as you see here, it doesn't mean that it's been included in the project. So we need to include our math library. Include C math. I'm gonna run this, save it. Oh, missing my closing parentheses there. And oh, the while I put it inside the parentheses instead of outside, and that's proper syntax there. Degrees C. Okay. Enter a temperature in Celsius under 10 degrees. I'm going to test out my input validation first, and I'm going to put 45 degrees Celsius, and it should loop back and ask me to enter that degrees Celsius temperature again. And so let's try something that's in that proper range, maybe 4 degrees Celsius. Okay, enter a wind speed in meters per second. How about 2.5? Wind chill index is 4.05. Okay, so anytime you have code that that you can separate out and make it its own standalone module, it's typically a good idea to do that. Although for this particular program, our function is only a one-liner here, calc wind chill, and then this get data. It may seem like, well, we could just put those back in the main and it would be fine. Yeah, that may be true for these smaller programs, but the larger your programs get, any time that you have code that might need to get executed over and over again at different points in the program, but not necessarily in a loop, that's when you want to create your own separate user-defined functions. And actually the next project we will do in chapter 6 will involve creating these functions that we actually call more than once. So far in these chapter 4 and chapter 5 programs that we've done together, we've only called the functions that we wrote once. So again, it may seem like it's unnecessary and extra work to push it out into a separate function, but as I said, we will soon see that there are programs where it will save you having to write that code more than once. This concludes our chapter 5 guided practice. Happy programming. Know yourself.